For question 4, this is going to be an acid-base question. It tells you phenol is a weak acid that partially dissociates in water according to the equation above. What is the pH of a 0.75 molar phenol solution? Well, because this is a weak acid, I need to write out an ice chart. Okay, so I'm going to show this reaction. Remember, you're going to put a big X for water because we're going to ignore it. I know the initial concentration of phenol is 0.75. Initial concentration of its conjugate base and hydronium are both going to be 0. Okay, the change is going to be minus X for the reactant and plus X and plus X, which means your Ka, when you do this, okay, your Ka, we know it. Your concentration of C2H5O minus is going to be X. Hydronium is going to be X as well. Your concentration of phenol is going to be 0.75 minus X. We're going to assume that X is much smaller than 0.75 because your Ka is so small. Okay, so remember the rule of 100.75 divided by 1.12 times 10 to the negative 10, that's going to be quite a bit larger than 100, so you're good. Okay, so we're going to cross out the X. We're going to multiply the 1.12 times 10 to the negative 10th by 0.75. And then we're going to square root that, and we get X is 9.2 times 10 to the negative 6. Okay, that's your concentration of your H3O+, so you just need to take the negative log of that. Remember, you have 2 sig figs, which means you need 2 decimal places, so your answer is going to be 5.04. So you got 1 point for the correct setup and 1 point for the correct pH. Okay, now it says for a certain reaction involving C6H5OH, proceed at a significant rate, the phenol must be primarily in its deprotonated form. So it must be C6H5O minus. Okay? In order to ensure that phenol is deprotonated, the reaction must be conducted in a buffered solution. On the number scale below, circle each pH for which more than 50% of the phenol molecules are in the deprotonated form. Okay? So, if I have more of the deprotonated phenol, what that means is that my pH is going to be larger than my pKa. Because remember, when they're equal, when I have equal amounts of weak acid and weak base, my pH equals my pKa. But if I have more base, if I want more base, what that means is my pH is going to have to be greater than my pKa, which means my pH is going to have to be bigger than 9.95, because that's what my pKa is. So that means that my pH is going to have to be either 10, 11, 12, 13, or 14. So that's your answer. Okay? And then have that exact same justification, exactly how I just explained that. Okay?